Hello everybody, Julian Charles here of themindrenewed.com, podcasting to you from the depths of the Lancashire countryside here in the UK. Now, returned from our half-term break, and today is the 6th of November 2013, and it is my great pleasure to be speaking to Dr. Michael Behe. Dr. Behe is Professor of Biochemistry at Lehigh University in Pennsylvania and one of the leading figures in the intelligent design movement. He's also a Senior Fellow at Discovery Institute's Center for Science and Culture in Seattle. His research centers in the evolution of complex biochemical systems and on the delineation of design and natural selection in protein structures. And in addition to dozens of peer-reviewed articles in biochemical journals, he's also written 2 books that challenge Darwinian orthodoxy. In 1996, he wrote Darwin's Black Box, the biochemical challenge to evolution, which helped to launch what has since become known as the intelligent design movement. And in 2007, The Edge of Evolution, the search for the limits of Darwinism. And strange though it may sound, one of the main things for which Dr. Behe has become famous is for traveling around the world talking about mousetraps in order to explain intelligent design to people. So I'm very much hoping that will come into our conversation at some point. First, let me say, Dr. Behe, thank you very much indeed for joining us on the program. It's great to have you on.
Yeah, it's great to be with you, Julian.
Now, before we get into any of the details of intelligent design and your particular approach to that subject, I wonder if you could just tell us a little bit about yourself, because I think that's often helpful to give some sort of background to these conversations. So could you tell us a little bit about your life and work and perhaps where you're coming from in terms of a worldview?
Yeah, sure. I was born in Altoona, Pennsylvania in 1952, and I was born into a Roman Catholic family and was and still am practicing Roman Catholic. And I went to parochial schools, and we were taught Darwin's theory in parochial schools. Of course, the sisters that taught me were theists, were believers in God, but the Catholic Church, it was never a problem concerning biological evolution. We thought that, well, God might have set up the laws of the universe and let them kind of produce the life that was in it. And that sounded fine with me. And so I never had any difficulty with Darwin's theory. And I went to college in Philadelphia, Pennsylvania, and got my PhD in biochemistry and did a postdoc at the National Institutes of Health and then eventually came to Lehigh as a professor of biochemistry. And all the while, I thought Darwin's theory was just fine. I didn't give it much thought. It wasn't my area of concern. Until I read a book in the late 1980s by an English scientist. His name was Michael Denton. He was working in Australia at the time. And the book he wrote was called Evolution, a Theory in Crisis. And he pointed out a number of problems for Darwin's theory of evolution that I had never thought about, and I had never heard anybody mention it to me, even though at the time, here I was a professor of biochemistry at a good university in the United States, and I thought that I should have heard about this if it was important. And after reading his book, I got mad because I thought that I was being taught to accept this theory not because of compelling evidence, but because that's just the way we think these days. Mm-hmm. And so after reading his book, I then went into the science library. And as a biochemist, you're taught, of course, about all the amazingly complex systems that underlie life. And I wanted to see who had explained some of these systems in terms of Darwin's theory. And I was astonished to find that nobody had. And so at that point, I became very skeptical of Darwin's theory and eventually came to the conclusion of intelligent design. And I guess that's how I got to where I am today.
Well, that's very interesting then. So you didn't start off by looking for problems with evolution because you had this presupposition that it conflicted with your faith or anything like that?
No, not at all. As a matter of fact, I remember sometimes when I was a postdoc at the NIH, I kind of met some evangelical Christians, and we had some discussions about evolution, and I was merrily making fun of their views. They were skeptical of it, and I thought, well, science has shown this, and so I had no problems accepting it at all until I read that book.
Mm-hmm. Well, I'd like to turn to your first book, Darwin's Black Box, which I have to say I read back in, I think it must have been about 1998, and I read it with enormous interest. It's a fascinating read. You argue in that book that the evolution of complex biochemical systems, such as living cells, that they're not really well explained in purely Darwinian terms, but that intelligent design has a much greater explanatory power. So I think that the first thing we really need to do is to pin down this term, intelligent design. So could you give us some sort of definition that we could work with?
Yes. Intelligent design is the purposeful arrangement of parts. That is, when you take separate parts that don't have anything to do with each other, and you put them together in relationships so that now they do something beyond the parts themselves, then that is a hallmark of intelligent agency. And that's how we recognize design whenever we're looking around. I mean, we're very good at recognizing design. If you walk down the street and you see on your right there's some, crabgrass and various plants and weeds and in the lawn on your right, and you look to the left and you see a neatly arranged flower bed with a row of red flowers and yellow flowers and so on, you easily come to the conclusion that the one that is purposely arranged was the result of intelligent design, not of random processes such as the one on the right. And this was a hallmark of the perception of design even back in Darwin's day. For example, William Paley talked about the arrangement of the eye, arrangement of many things in life. So the purposeful arrangement of parts is the undergirding definition of intelligent design, and that's how we discern it.
I have to throw in at this point that I suspect somebody like Richard Dawkins, for example, would immediately say, well, what you're seeing there is the appearance of design. How do you know that it's designed and it doesn't just look to you and you're being fooled?
Yeah, that is, of course, what Darwinists come back. They say that, no, it's just the appearance of design. We've got this other idea, Darwin's theory, about how to account for it. Well, I'd respond in two ways. You have to ask yourselves, why does it appear designed to Richard Dawkins or others? And it appears to them to be designed just the way that it appears to us to be designed, through the purposeful arrangement of parts, through the apparent arrangement of separate things to be able to do something complicated. And so we both agree on how we come to a conclusion of design. Now, as you say, Dawkins would say, no, this is just an illusion. Mm-hmm. And at that point you ask, okay, let's see your data. Let's see the demonstrations or the indications that Darwin's theory can, in fact, mimic design. And we're living in an age of great progress in science these past 30, 40, 50 years. And one thing we've been able to do is kind of delineate what random mutation and natural selection are capable of at the DNA level, at the genetic level, and the level of molecules. And as I point out in my two books, we don't have any experimental or good scientific evidence to show anything like anything that would support the assertion that random mutation and selection could build such things. And in the absence of an alternative explanation, in the absence of anything that can actually produce the appearance of design other than intelligent design, then I argue we're perfectly justified in concluding that the design we see is real.
And one of the main things that you point to, particularly in your first book, is this notion of irreducible complexity, which is a feature that you say of living systems that sort of tips us off to the probable fact that these things are designed. And this, of course, is where your mousetrap analogy comes into play. So I'm inviting you here to introduce us to the mousetrap. Could you explain to us what irreducible complexity is and how it serves to indicate design?
Sure. When Darwin wrote on the origin of species, he had a section in there entitled Organs of Extreme Perfection and Complication. And in it, he discussed things like the vertebrate eye. And scientists even at that time knew that the eye was a very complex organ. It had a lens and a retina and muscles and tear ducts and all sorts of things. And he nonetheless thought that such a thing could be put together gradually. But at the end of the section, he said, if it could be shown that there existed any organ which could not be produced by numerous successive slight modifications, my theory would absolutely break down. And he added that he didn't know of such an example. And he was always insistent on this gradualism, that evolution had to work over long periods of time in tiny steps, improving things just a little bit at each step, because he knew if things improved quickly in large leaps, then it would look suspiciously as if something other than random changes were involved. Mm-hmm. But if you think about it, ask yourself, well, what sort of a thing couldn't be put together by numerous successive slight modifications where each step improved or at least didn't degrade the system that was under construction? Something which is what I term irreducibly complex kind of fits that bill. It's just a fancy name, but it just means you've got a machine or a system or something that has a number of different parts, and all of the parts have to work together in order for the system to function. And in the absence of one or more of the parts, the function of the system is lost. And that's where I brought in the example of the mousetrap, because it's something everybody's familiar with. A mechanical mousetrap has a number of parts. It's got usually has a wooden platform and a metal spring and a metal bar which snaps over and squashes the mouse when the spring is tripped, and another bar to stabilize it in position. And it's got, half a dozen different parts which are very precisely arranged, and if they're not precisely arranged, the trap is either already tripped before a mouse comes along, or it simply doesn't work. So the question is, how do you put something like that together by numerous successive slight modifications? And it turns out to be extremely difficult, even for a simple mousetrap, to figure out how one could do that in, say, a random manner, not a directed manner like an intelligent agent would do. Well, I went on to point out that science has discovered that there are many, many systems like this mousetrap that have many parts needed for their function, which exists at the molecular level of life in cells and at the very foundation of life. And so I've argued that this is where Darwin's ideas break down.
So if we take the general Darwinian narrative here, the idea would be that you would have to have some sort of precursor to these various systems that you're looking at, these biological systems, and they would need to be simpler because you need to move from one step of complexity to another step of complexity gradually upward towards this whatever organism that you're looking at. And you're saying that there are irreducibly complex organisms, systems, which it has not been shown that there are any simpler versions at a previous state of evolution that could lead up to these organisms. Have I got that right?
Well, sort of. They're not necessarily have to be simpler versions, and there aren't simpler versions of many biochemical systems. The point is that even if you have simpler things, you've got to go along a very, very narrow path in order to get to anything more complex. And while you're doing this, when you're taking the steps, you are not improving the system at all. You're just kind of building it up and hoping against hope that something will turn up in the future.
Mm-hmm. So it's very unlikely that those particular entities would survive in the struggle for existence.
Well, it's unlikely that they would be produced at all. You think of it in terms of the mousetrap. It's a lot easier. Suppose that in your garage, you had a number of different pieces of junk. You had maybe a spring from an old clock, or you had a metal bar, say a crowbar that you thought you might use as a piece of a mousetrap, and suppose that, every now and again something blew together and would fall on each other. How long would it take before random pieces of metal parts in your garage would come together to form something like a mousetrap? And what intermediates would they form that would be helpful along the way? And when you think of it that way, you realize that it's an extremely long time, and practically it would never do that. This is the sort of problem that Darwin's theory faces. And the machinery of life is a whole lot more complex than a mousetrap is.
Yeah, sure, indeed. But I'm going to have to throw this back at you. Of course, as you well know, John MacDonald, professor of biology at the University of Delaware, has criticized your mousetrap analogy and has said that, well, in fact, it's not irreducibly complex because you could conceive of simpler versions of the trap that have certain bits, not other bits, but they could still function to catch mice. So
what's the problem?
Yeah.
yeah. Good question. What's the problem? I've seen, of course, his objection, and I don't think he realizes what he's doing. He's making a series of mousetraps. He starts with something that he says has one piece, and it's kind of like a spring, and then he says, well, let's bring in another piece, and he says to improve it, and so on. But if you look carefully, with an eye to where he might be using his intelligence, rather than random processes like Darwin's theory postulates, you see that he starts from a very specific starting point, a spring with very special properties, and then in the next step, he hopes to add just a wooden platform under the spring, and it turns out he adds a couple of staples too, but he just doesn't realize it, and he changes the shape of the spring, and all of these things he does just to get from a putative one-piece mousetrap to a two-piece mousetrap, and the whole series just exudes intelligent direction. But Darwin's theory can't postulate or can't use intelligent direction. So his rebuttal is, when you look at it right, is just a wonderful example of why it's so difficult to make irreducibly complex systems in a random manner.
And he has a series of pictures where he shows the mousetrap with certain parts and then others with other parts and the like. Would you say that each picture, in a sense, is a small example of irreducibly complex system in itself?
Yes. What he has is a number of irreducibly complex traps. I never said you couldn't make a mousetrap a different way. You can make them various ways. But the question for evolution is, how do you get from a simpler one to a more complex one to the one we see today? And he shows a number of them, but you couldn't get from one to the other without intelligent direction. And if it's such a problem with these relatively simple traps, even when somebody as intelligent and motivated as Professor MacDonald is trying to do it, then I think most people can see the problems for unaided nature to do the same thing.
Mm-hmm. Now, in your first book particularly, you point to a number of complex biochemical systems that exhibit this feature of irreducible complexity. And the most famous one, of course, is the bacterial flagellum, and this has become a bit of an icon for the intelligent design movement. Could you give us, I mean, obviously you won't be able to go into much detail here, but could you give us some idea of how systems like the flagellum show themselves to be irreducibly complex?
Sure. Let me just first say for anybody who hasn't heard of it that the flagellum is pretty much an outboard motor that bacteria use to swim. And like an outboard motor on a boat in our everyday world, it's got a number of parts. It's got a part that acts as a propeller, a part that acts as a motor to spin it around and around. It's a rotary motor, one of very few known in nature. It's got parts to kind of clamp it on to the bacterial membrane, just like an outboard motor has to be clamped onto a boat to work. And it is, as you say, an icon of the intelligent design movement for good reason, because when you look at an illustration of the flagellum, virtually everybody immediately sees the problem for Darwinian mechanism in trying to put this together. And you immediately grasp the design behind it. It looks like a motor. It looks like a mechanical device.
Yeah. That's very striking, isn't it? Yes, indeed.
Yeah. I don't know if your listeners, a month or so ago, there was a story about an insect that had gears between its legs to help it hop. Right. It's called a plant hopper, I think it was called. And you could see immediately the mechanical principles behind it, and it sure looked designed. Well, let me just say that the flagellum is that, raised to the, 1,000th power or so. It's just much more sophisticated and much more obviously mechanical. And if you take away a part of the flagellum, it doesn't work. If you take away the propeller, it can't propel the bacterium through any liquid. If you take away the clamps that keep it on the bacterial membrane, it falls off. This is not, very mysterious why it doesn't work. It's not hard to see. It's just like, a bicycle. If you take the wheels off, it's not going to work very well. And the same thing with the flagellum. And so that's why it's irreducibly complex.
And yet Kenneth Miller at Brown University says that, well, it isn't, because there is in fact a kind of subset or a sub-feature of the flagellum. Is it called the type 3 secretory system?
Yes.
Which has function and in some ways looks like it's a kind of simpler form or something of the bacterial flagellum. And so he says, well, there you go. There's something which is indicative of a step
sure.
in the evolutionary process. So what do you think that objection holds water?
Well, bless his heart. He's such an optimist, I'll tell you. No, I disagree with him, and here's why. When I wrote about the flagellum in '96, this other feature, as you say, the type 3 secretory system hadn't been yet recognized. And briefly, the flagellum was discovered to be more complex than was thought in 1996 when I wrote the book. It turns out that unlike an outboard motor, the flagellum has to build itself, or the cell has to build the flagellum. And part of a flagellum is an active pump, which pumps out parts from inside the cell through the inside of the flagellum. It is hollow in order to allow it to build itself, and pumps these parts out towards the tail to extend the tail. Now, if you think about it, if that feature was not part of the flagellum, say it was solid and it was built by some other mechanism, then we still would not have explained any of the rotary function of the flagellum. We still haven't explained why is it a rotary motor. The fact that it does this other thing, pumps things out to help build itself, does not explain the function that we were focusing on at all. It's just something that makes the problem for Darwinian evolution worse. Let me go back and use an analogy to everyday objects or everyday machines that might bring the point home. Suppose somebody saw a car for the first time, and they saw that it drove down and you needed a steering wheel and you needed the tires and so on. And somebody said, well, you need all of these things for it to work. And later on, a person opened up the hood and discovered the gas pump inside the engine. And they said, aha, look, a gas pump. This pump can work even without the car. We can use it to pump gas from one container to another. So that explains how the car came. Well, of course, it's silly. It doesn't. It's just another problem to try and explain. And the fact that it can pump gas doesn't explain how the car can roll and its tires are moving and so on. In the same way, the fact that the flagellum has this pumping function does not explain at all how it got to be a rotary motor, an outboard motor. It just makes it worse.
Sure. So going back to that car analogy there, you could look at each component in the car and you could say, well, if it were in fact the case that each thing does actually function in its own right, but then you've got to bring all those things together fortuitously, presumably, and it just all happens to work as a car.
Yeah. And that's another thing that folks don't appreciate, that in our world, intelligent agents put together cars and they put together outboard motors. But in the cell, the parts have to assemble themselves, or something has to assemble them. And that turns out to be a whole nother level of complexity. This is being done kind of robotically, so it's kind of like having a robot factory which assembles cars. Not only do you have to explain the function of the car itself, you have to explain where did these robots come from that can assemble the cars. And that's, like I say, a whole another level of complexity.
Indeed, and that's something that you bring out in your second book, The Edge of Evolution. Before we turn from the first book, Darwin's Black Box, I'd like to just ask you one or two extra questions about that. And the first one is, why did you actually call it Darwin's Black Box?
Well, in science, the term black box has a different meaning than it is in aviation. In aviation, it's the recorder of flight details. But in science, a black box means some system or some machine that is doing something interesting, but you don't know how it works because you can't see inside the box. It's black, it's closed to viewing. And to Darwin and his contemporaries, the cell was a black box. It did interesting things. It divided, it could move, sometimes swim, but they didn't know at all how it worked. They thought that the cell was a simple glob of jelly, protoplasm, they called it. And I named the book that because in the ensuing 150 years or so, science has opened that box that was closed to Darwin and his contemporaries, and now we see what is inside it. And I argue that the contents of Darwin's black box is what kind of overthrows his theory.
So inside the black box, then, we very much see complex machinery. Would you say that's a correct way of calling it?
Absolutely, and it's not just me. If you go and look at the titles of science papers, the term molecular machinery is widely used, and terms gears and motors and all sorts of mechanical terms are used widely, and they're used widely because they fit the description of the cell. There are literally molecular trucks that carry supplies from one end of a cell to another, and there's little molecular signposts that tell the truck when to turn off the road, and there are unloaders which open up the truck and take the contents out and make sure they go to their correct destination. As a matter of fact, this year's Nobel Prize in Medicine in 2013 went to scientists who worked on exactly that problem. How does intracellular transport work in the cell? And they've shown that it's essentially like the interstate highway system in the United States, with trucks and vehicles taking supplies various places, and it's much more complex than a layman might think.
So you already mentioned Paley, of course, but in that respect, then Paley was right. You would say, would you, that to look at nature and liken it to a watch, to a mechanism?
I think he was absolutely spot on that particular point. His famous opening lines to his book about finding a watch in a meadow, he was absolutely right. If you picked up a watch that you had just stumbled upon in a meadow, you would immediately recognize it was designed. And for the reason that he said, because you'd see how the parts are fitted to each other to produce the function of keeping time. Where I think he kind of went off the rails is that he tried to extend this indiscriminately to many features of nature. And he also tried to make an argument for goodness in nature and morality and many things that went beyond the basic observation of design.
And this also has implications for what David Hume said, where he said that it's just illegitimate to assume that nature is mechanical, and that you could liken nature to the growth of a vegetable or something. But actually, he was wrong. It is correct to liken nature to that.
Yeah, it turns out we know more about nature than he did, and it turns out that nature is mechanical, not because of our imposing any ideas on nature, but because it uses force and it moves things, and it uses all the mechanical principles that we recognize in our everyday world. And so Hume, as well as Darwin and his contemporaries, I think have been overthrown by the progress of science.
Now, in your first book, you say that the scientific literature is pretty much empty of Darwinian explanations for these complex systems that you're talking about. Now, that was back in 1996. Has that situation changed?
Well, yes and no. No, it hasn't changed in that there are still no explanations for any of the systems that I wrote about. Nonetheless, since my book came out, it has kind of angered a fair amount of the scientific community. A lot of folks, when they publish papers, specifically add little zingers or add little lines saying, well, this shows that irreducible complexity is wrong, or this shows that intelligent design is a bunch of blarney. But if you look at them, and I have a blog, and I write on the Discovery Institute's website as well, and when these come up, I oftentimes write responses, and I urge any listeners who are interested in the back and forth to go and read those. And if you look at the details, none of them go any part of the way towards explaining the systems I talked about. And I would say that the argument of John MacDonald is probably better than most of the arguments that one reads in the science literature. And as I tried to explain a little while ago, his argument misses the point and is actually a good argument for irreducible complexity in intelligent design.
But as you say, you'd actually have to go and read those papers, because you couldn't just do a word search or keyword search or something like, intelligent design disproved or anything like that, because that would come up with a lot of hits. But
yeah, that's right. And if you write in Darwinian evolution, I give up, you won't find many of those phrases either. Yeah, I'm afraid you have to delve into the details.
I'd like to turn now to your second book, The Edge of Evolution, and you explore the limits here of what undirected Darwinian evolution is actually capable of achieving, and you do this by looking at what you call the trench warfare between malaria and sickle cell disease. Could you tell us what that suggests to you about the limits to Darwinian evolution?
Yes. We know the most about the genetics of humans and our parasites because we're interested in our health, of course, and so science pays particular attention to us and our enemies, our genetic enemies. And the most severe disease that afflicts humans, infectious disease, is malaria. Malaria, many people in Northern Europe and the United States don't think of it much these days because it's pretty much been eliminated in the past half century or so. But it still kills 1 million people a year, mostly small children in Africa and the equatorial regions. And it sickens 100 million people a year. So it's an extremely prolific disease, very frequent. And if you think about it, any human who was born with a mutation that conferred a bit of resistance to malaria would have a great advantage in the malaria-infested regions of the world and would tend to survive and leave offspring. And if the offspring inherited that mutation, then they would go on to prosper better than other folks, and you'd have a classic case of Darwinian selection. Well, it turns out that exact scenario has happened a fair amount in the past 10,000 years. And the most widely known example of a mutation is that for the sickle cell disease. And it's shown in almost all biology textbooks as a classic example of Darwinian evolution. And Darwinists have touted it as showing the power of their theory for decades and decades. The problem is that, of course, the sickle mutation is just one small change in a pre-existing system, that of the hemoglobin in your red blood cells. It's not a mutation in the immune system, which usually takes care of microscopic parasites, which malaria is. It's a single-celled parasite. And, of course, it has these terrible side effects, too. Although if a person has just one gene for sickle cell, then they have resistance to malaria and they don't have any other health problems. But if they have two genes, then they have sickle cell anemia, and that itself is deadly. So it's not a real elegant solution to the problem of malaria. Well, it turns out that in the past few decades, because of the advance of science and our ability to sequence genes and genomes, a number of other mutations have been discovered that give a bit of resistance to malaria. And one class of them is called thalassemias. And in thalassemia, the gene for a part of hemoglobin, either what's called the alpha chain or the beta chain, is broken. It's turned off so that it can't produce any functional protein. And for some reason that helps. But it's not on the way to building a new system. You've just broken a part of a pre-existing system. And there's another mutation that's very widely spread called glucose 6-phosphate dehydrogenase deficiency.
Thank you very much for that. Yes. That? Tests at the end of the podcast, yeah.
And it turns out that in that, the gene for the eponymous glucose 6-phosphate dehydrogenase is broken. it again is deleted so that people who used to be able to make this, and it's a useful gene to have, no longer have it. And that gives a little bit of resistance to malaria, but at the cost of losing something that was already working. So the conclusion is that the great majority of the genes, or there's only half a dozen or so, but the genes that have mutated in response to pressure from malaria break things. They break pre-existing functional systems. The only one that doesn't is the sickle cell mutation, and that causes different problems of its own. None of them are on the way to building molecular trucks or buses or control systems or computers or any of the other types of machinery that have been discovered in the cell.
Just at this point, I'm wondering if somebody might be skeptical, saying, well, then why have you chosen to look at malaria there? Is that because it shows what you want it to show, or could there be other examples where what you're saying doesn't apply?
Yeah, there are a number of examples. I looked at the malaria because it's the most widely studied, and because the number of organisms with people, there are billions of people, and there are astronomical numbers of malarial parasites involved, so that if there was any chance of it producing something rare but very helpful and constructive, then that is the place where you would expect to find it. But yet we don't find it there. But other places to look are actually in the laboratory. In the past couple decades, scientists who are interested in evolution have tried to reproduce it in the lab by growing flasks of bacteria for long periods of time over generation and generation. And the idea is that if a mutation arises in the bacteria, and they're in just one flask, you can have billions and billions, trillions of bacteria, then you'd be able to see classic Darwinian evolution unfold before your eyes over a couple decades. And exactly this has been done by a man named Richard Lenski at Michigan State University. And he has grown a bacterium called E. coli for over 50,000 generations, which is more than 1 million years in terms of human generations, and many, many individuals, trillions of bacteria. And what he's seen is that the bacteria improve. They get better at growing, and they grow faster than the initial bacteria did over time. But when he tracked down the exact mutations within the past 10 years, because only in the past 10 years have we gotten so good as to be able to sequence the DNA of bacteria very easily, he's seen much like what we see in the case of malaria. That is, the improvements were actually the breaking of genes. As a matter of fact, one of the first mutations he discovered was a strain of bacteria that had thrown away the genes to make the bacterial flagellum. And the reason is that, he had a shaking culture of bacteria, and they didn't need to swim themselves because the liquid was agitated. So they didn't need to spend the energy to make this complex system. And so a bacterium that deleted that, or had a mutation in which it was thrown away, was using less energy for that and had more energy to grow than other bacteria. And he discovered maybe 30 other mutations, and they were all degradations or deletions of pre-existing machinery. There wasn't anything that was on its way to building, again, a new truck, a molecular truck, or molecular processing system. So when you see that in humans and bacteria, you get confident that that's what Darwinian evolution does. The dreams of Darwinists notwithstanding, it breaks things much, much more easily than it makes them.
Mm-hmm. So this is why you liken it to trench warfare rather than as an arms race, is what Darwinians often say. That the idea, of course, with the arms race is that you have this improvement as each side is fighting against the other, but you call it a trench warfare.
Yeah, that's exactly right. I think Richard Dawkins in one of his books and other Darwinists have said we have this evolutionary arms race, and we start with just maybe slingshots, and then we get guns, and then we get machine guns, and then we get nuclear weapons, and things get better and better, you see.
So in fact, what we actually have is we have a bow and arrow with one side and a revolver the other side, and little bits are taken off each and replaced, and bits are taken off again, and it just goes around in a circle.
It's actually what we do see in real warfare, that we can start off with two civilizations that are advanced, and they start to fight each other, and they pretty soon go from advanced weapons down to bows and arrows, and then down to slingshots, and then just down to rocks. They lose whatever capabilities they had with the warfare.
Mm-hmm. I'm just wondering at this stage whether you think it's a good idea to talk about protein bonding at all, given what you've just said, how that indicates just how big the challenge is for undirected evolution.
Yes, in my second book, The Edge of Evolution, I kind of try to broaden the argument and ask what exactly can random process, Darwinian processes, account for. And I talked about something I alluded to earlier, the need for proteins or the parts of the machines to stick to each other in the correct way. Again, in human society, intelligent agents build machines. People build cars and computers and so on. But in the cell, the parts have to kind of stick to each other. They have to attract each other through electrostatic interactions, other things, in the right way. And it turns out that's a very difficult thing to do and would need multiple mutations in order to get two parts to stick together without sticking to anything else. And I concluded that if you needed more than two proteins or more than three proteins to stick to each other in a specific way, that was more than you could expect Darwinian processes to produce in all the organisms that have ever lived in the 4 billion year history of the Earth. And so anything with more than three protein parts, I concluded, had to have been designed. And it turns out that most of the machinery of the cell works as complexes of at least half a dozen parts. A few things work by themselves, but most work in aggregates of 6 or more. So I concluded that the cell is pretty much altogether a product of design. It's not just this molecular machine or that one, but the whole cell, the cell as a whole.
So you're throwing out another formidable challenge there to the scientific community. And of course, this is 6 years since you wrote that book. So has anybody come back to you?
No, nobody has. And if you look at these evolutionary experiments, again, they don't produce new specific binding sites. They break things. Some people have tried to analyze pre-existing machines and how they can be put together, but it's a lot like John McDonald's work on the mousetraps. They're using their intelligence. They're not really letting random processes build things up. So the long and the short is that, no, this has not been answered since I wrote the book.
Okay, so I'd like to ask you to respond to a number of objections that I have here, and I'm going to say straight away that I'm not personally persuaded by these objections, but I have to play devil's advocate.
Sure.
So I want to do that with reference to the Kitzmiller versus Dover case in 2005, in which you were a witness for the defense. Now, this was, of course, the challenge in court brought against the Dover Area School District in Pennsylvania for requiring that schools teach intelligent design, and it's my understanding that it was ultimately Judge John E. Jones's decision that ID shouldn't be taught, and for a number of reasons. And what I'd like to do is to ask you about some of the reasons that he gave for reaching that judgment.
Sure.
So first, there's the main claim, I think, that intelligent design is essentially a form of creationism. It's a religious doctrine, and so to teach it would be to fall foul of the establishment clause of the separation of church and state. So is that right? Is intelligent design a form of creationism?
No, that's completely wrong. Intelligent design is an empirical theory in the sense that it is the result of observation of what we have seen in life, the molecular machinery, and straightforward logic. That is, how do we deduce whether something is designed or not? And as I said, it's the purposeful arrangement of parts. None of that appeals to any religious doctrine, anything supernatural, anything at all other than the structures of the machinery and the logic behind concluding how something is designed. And let me just say that there have been instances in the history of science before that people did not like a new theory because it pointed to something beyond nature. I think that the best recent one is the Big Bang theory. Many people forget that Big Bang theory was first proposed in the 1930s and 40s, and that made a lot of people uncomfortable because they thought that a beginning to the universe pointed to something beyond the universe as its cause, a religious cause. Maybe this was the creation. Maybe God caused the Big Bang. And a lot of people didn't like it, including a lot of scientists. There was a man, Walter Nernst, who said that this science requires an eternal universe and that the Big Bang theory is just creationism or just religious. And as recently as 20 years ago, the journal Nature, which of course is the most prominent science journal in the world, ran an editorial with the very interesting title, "Down with the Big Bang," in which they called the Big Bang theory philosophically unacceptable, and they called people who proposed it creationists. So this is just rhetoric. Judge Jones, I don't think Judge Jones, he might be a perfectly fine man, intelligent, good law judge and so on, but I don't think he understands anything about science or the history of science, and he just signed on to the argument made by the other side. But essentially it's just a rhetorical device to try and stop people from considering an idea that you don't like.
So when an individual does actually decide for themselves that they think, well, okay, intelligent design as a theory has something going for it, I believe that the designer is the Judeo-Christian God. That is a personal decision. It's not actually within the intelligent design theory itself.
That's right. You can be like me. I think that God might have started the Big Bang, and I think it might have been the Judeo-Christian God that started the Big Bang. But if you look at the redshift velocities of the stars and galaxies, they don't say who started the Big Bang. In the same way, I think the flagellum was designed. I'm a Catholic, Christian. I think the designer is very likely to be God, and I believe in the Christian God, so I think the designer is very likely to be him. But there is nothing on the flagellum that precludes somebody from making another suggestion for who the designer might be.
So, in fact, the very popular thing about the flying spaghetti monster, Pastafarians, I think they call themselves, this just misses the mark then, really, because I presume such a person is quite within their rights to think it was the flying spaghetti monster, but this doesn't touch the intelligent design theory at all.
Exactly. Go ahead if you think it was this creature, flying spaghetti monster or whatever, but if you're going to convince somebody else that it was a flying spaghetti monster versus the Judeo-Christian God, you're going to have quite a burden on your hands. But if you want to convince people that the flagellum was designed because it requires multiple parts interacting to perform a function, I think that's much more persuasive.
Okay, that brings me to another one of these objections, and here this is the idea that intelligent design invokes and permits supernatural causation, therefore it's not scientific because it does that. And here's a quote from Judge Jones: "Expert testimony reveals that since the scientific revolution of the 16th and 17th century, science has been limited to the search for natural causes to explain natural phenomena." So does ID invoke and permit supernatural design?
No, I think Judge Jones' ruling is wrong as a matter of fact and as a matter of history. As a matter of fact, the assertion that intelligent design invokes supernatural entities is the same as saying that it's a form of creationism. It isn't. It's just looking at physical objects that we've discovered, the molecular machinery of the cell, and following the same logic that we use to conclude that anything else was designed. If somebody wants to make the claim that the designer is supernatural, as some will, they are welcome to make philosophical or theological arguments about that. But intelligent design, the scientific theory of intelligent design, doesn't have to make that. In the same way, the cause of the Big Bang might have been a supernatural event, but the Big Bang theory, the scientific theory that the universe had a beginning, does not have to make that. Additionally, I think Judge Jones is following mistaken history. It's well into the 19th century that most biologists thought that something like intelligent design was true. William Paley's work was well received, not only in popular circles, but in scientific circles too. It was Darwin's work itself that was trying to show that design was not necessary, which shows that design of living systems was an active idea, at least until Darwin's work came out. So I think it's a tendentious argument that was made by the other side, and Judge Jones just signed his name to it.
Yeah. I think the objection, which I think most people would think has the most going for it, is one where he says that its ID is logically flawed. And I think there he's pointing to the fallacy of false dichotomy. So I think the suggestion here is that just because Darwinian processes seem inadequate to explain such phenomena, that doesn't mean that design must therefore be the answer. There might be other as yet unexplored mechanisms. We need to just give science time to discover that. We're jumping the gun, as it were.
Yeah, that is certainly a frequently heard argument. I think that's wrong too. You might not be surprised. And that's because we are not saying, look, Darwinism can only produce this, a certain amount of change, therefore intelligent design is the explanation. We're saying, look at the purposeful arrangement of parts. Look how precisely these things interact with each other. Just like in a mousetrap, in a simple mousetrap, when we see such precision of interacting parts, we know that required design, because only intelligence can arrange things out of the swirl of things that are happening in the world to order them to each other to produce an effect. That is the positive argument for design. And the fact that we have to argue against Darwinism because Darwinism claims to be able to explain things that most people think were designed, that's only a kind of a side effect. We're just clearing away the clutter so that people can believe what their eyes show them. Additionally, some people have said, well, you're jumping the gun. Well, maybe Darwinism can't explain it. Maybe things do look designed, but maybe there's another theory that will eventually explain the appearance of design. And I respond to that, well, maybe in science you can't ever rule anything completely out. New data might come in the future, but right now, with the evidence we have in hand and with the understanding we have in hand, intelligent design is the best explanation. If you think in terms, again, of the Big Bang Theory, suppose that the people who didn't like the Big Bang Theory when it was first proposed said, you're jumping the gun, you're proposing this theory that has all these unpleasant philosophical implications. Let's wait around a while, and maybe in 100 years, science will come up with an explanation that avoids a beginning to the universe. And if that view had prevailed, then science would have been stalled, and a lot of good work would have been prevented. And I feel the same thing for the idea of intelligent design. It fits what we see today, and that's all that you can ask from science.
Yeah, so in that sense, it's no different from any other theory. It's tentative, like all theories. But as you say, that you make this inference to the best explanation, and that's the current state of the art. And whatever happens in the future, well, that may contradict it, it may not. It's no different from any other science.
Yeah, that's right. Science can't see into the future any more than anything else can. So we have to build on what we've got. That's what science has done in the past, and it's taken us a long way. There's no reason to lose courage at this point to suppress science in favor of a particular philosophical view that some people subscribe to. Yeah. We just work with what we have.
Absolutely. And I want to bring up, I think perhaps I don't know if you'll agree with me, but I think this is the weakest set of objections that were given here. Let me quote from him. He says, ID's negative attacks on evolution have been refuted by the scientific community. It is additionally important to note that ID has failed to gain acceptance in the scientific community. It has not generated peer-reviewed publications, nor has it been the subject of testing and research. Could you comment upon those various objections there?
Sure. Yeah, he's got some points, but of course, anybody who's familiar with the history of science would know that that's a frequent occurrence, that new ideas often encounter fierce resistance from people invested in old ways of thinking. And sometimes ideas that we now accept can be delayed for hundreds of years by the resistance of the scientific community. His assertion that ID has been refuted is, as we shall say, open to question. But I would just like to point out to the listeners that Judge Jones does not himself know what has been refuted in this area or not. He studied law. He studied liberal arts in college. And he's essentially taking the word of the other side. Yeah. And I would just point out that that may not be the best guide for what is correct here.
And there is peer-reviewed publication out there?
Well, you have to realize that in the scientific literature, you can't say the words intelligent design unless it's in a critical context. So I could not send out a paper that argued for intelligent design, and I would get it back in the next day's mail. But people who argue against it do explicitly talk about intelligent design. And if you look at their papers and if you read some of my replies, like John MacDonald, their rebuttals just go to show how difficult the problem is.
Okay, and I'm going to throw at you the big one, the one that's most common, and that is, I'm afraid that ID is just God of the gaps all over again. That's what you're doing.
Okay, yes, God of the gaps. I'd never heard of the phrase God of the gaps until I started working on evolution. Nobody else in science ever says, well, we've tested this theory, it doesn't work, but we better keep working on the theory because, we don't want to be accused of a God of the gaps or, abandoning a theory just because it doesn't work and we want to invoke something else. Now, again, intelligent design is not based on the assertion that we can't explain something. Decades ago, physicists couldn't explain why there were so few neutrinos being emitted from the sun, but nobody said, well, it must be because God made it that way. No, nobody made an argument for intelligent design based on the fact that we didn't understand something. Rather, it's the fact that we do understand things that Darwin didn't understand in his day. We do see what makes the cell run. We see that there's machinery. We see that there's precisely interacting parts. Therefore, the case for intelligent design is a positive one. It was a lot easier when we were more ignorant about how life worked, about the cellular and molecular foundation of life, to think that a theory like Darwin's could explain things. But an intelligent design has become more and more obvious, more and more insistent, the more we know about biology. So it's not an argument from ignorance. It's not a God of the gaps. It's an argument from knowledge.
I'd like to ask you if you could be a bit speculative for a moment. I'm wondering, this may be a thought that's in the minds of many listeners, how does design information actually get into the natural world, in your opinion? I mean, there's some people who say, well, it's all front-loaded, it's there at the beginning, but there are others who say that it's side-loaded, as it were. The information is coming in as the process of evolution is going on. What's your view on that?
Well, that's a good question, and the short answer is I don't know.
Mm-hmm. Fair enough, yeah.
I mean, one could speculate, or one could have a favorite theory, but it's my opinion that we simply don't know enough at this point how design is introduced into the world. But that's the nice thing, I think, about a theory of design, intelligent design, is that you can conclude that something was designed just by looking at it and just by seeing how it works without knowing the history of the system. You can open a garage and you can see a car in there, and you could open it up and see how the engine works, turn it on and drive it and so on. And it may have been created by God, 10 minutes before you opened the garage door, or it might have been made in a factory or something. You don't have to know the history of it, but you can tell just from the arrangement of parts in the car that it was purposely designed.
Mm-hmm. Okay, there's one thing that I must ask you, because I think to miss this out would leave people thinking, oh, well, they didn't address that part of it, and that is the possibility that all that you've been saying could be possibly explained by things like self-organizing principles, and some people talk about the possibility of chaos theory applying to these things. Do you give any credence to those at all?
Well, that is a great question, but it turns out these experimental observations and field observations on malaria and the laboratory experiments on E. coli not only rule out Darwinism, they rule out all other unintelligent theories as well. Just think about humans and malaria. The changes that have occurred have been mostly broken genes, degraded genes, and so on. But we were not there saying, humans, you have to change by Darwinian processes. Whatever could have happened to help the humans survive was free to happen over the course of the 10,000 years. And nothing did happen except, some small mutations and selection, kind of a classical Darwinian theme. And the same thing with the experiments of the bacteria in the laboratory over 50,000 generations. Nobody told the bacteria which mutations could occur in them, and if changes were available to happen by self-organization or complexity theory or whatever else people want to postulate, they were invisible. We didn't see them. We didn't pick them up. So I think not only Darwin's theory, but all unintelligent theories that only invoke unintelligent causes are ruled out by this data.
Fascinating. The last thing I'd like to ask you really is about the general attitude towards intelligent design in academia over there in the States particularly. Certainly over here in the UK it's rather frowned upon. I'm thinking particularly of the establishment's dislike of ID came over very strongly in that BBC Horizon programme which you were in. That was 2006, I believe, and they called it A War on Science, which was a very prejudiced title to start with. What's the general attitude over there?
Well, it's bad.
Right.
It's not a smart career move to declare that you think there's something to this intelligent design stuff. People have been fired. Students have been kicked out of laboratories. Really? The science establishment has made it as difficult as they can for people who hold these views, and I'm okay because I had tenure before I wrote my book. I'm no fool. So that's not good, but I'm still very optimistic in the relatively near term because the data of science is just accumulating and pointing more and more and more insistently towards intelligent design, and one can't resist the data forever. Hey, let me just make a comment about that. What was it, a BBC program?
BBC Horizon program, yes.
The Horizon program. That was interesting. The folks called me up and just said, hey, they'd like to interview me. And would I like to, bring my children and my family to an amusement park? They'd like to, film it against the backdrop of these mechanical devices that I talk about. And I said, yeah, that'd be great. And they were very friendly. And it was only later that I discovered that, I was being filmed riding in an amusement park ride and being made to look kind of dumb for doing so, and that this was in the context of a very strong attack against the things that I was talking about. So my advice to any listeners who are approached by people asking to interview you is be careful. Can't trust these interviewers.
Thank you very much. But you rest assured I have nothing to do with the BBC. Yeah. I've found similar things with other subjects as well. There seems to be a point of view, which there shouldn't be, but nevertheless there does seem to be.
Sure.
So what would your advice be? You've already touched on this really for scientists, especially students, who are actually persuaded by intelligent design arguments. Are you basically saying to them, shut up about it, keep quiet until you have tenure?
Well, if they do go into academic science, I'm afraid that's what I would advise them. Because as I've said before, I've heard of graduate students who were expelled from the laboratories they had been in because it became known that they supported intelligent design. So, yes, I'm afraid I would advise them to be very circumspect and wait until you have tenure or otherwise are very secure in your job before making any arguments or anything explicit on this topic. And that's unfortunate that it has to be that way, but that's the reality as I see it.
Yeah. And it's quite interesting that in itself speaks to the power of the idea, in that if the establishment really does need to be quite so antagonistic towards people, why? If it's such a bad idea, why bother?
Absolutely. And if Darwinism is such an overwhelmingly strong idea, why not just present it, alongside of any other comers? But people seem to act as if they think Darwinism is, number one, a very strong idea, and number two, that has to be protected against any rival idea. Those seem to be mutually contradictory there.
Indeed. Well, we're coming to the end of the interview, and I just wonder if there is anything that you feel we've missed out in the conversation that you'd like to add before we close.
No, I think it's been a very thorough discussion here. If I think of anything, I'll get in touch, though.
Great, thank you very much. It's been a great pleasure talking to you and having you on the program. It's your work, both your books have been very helpful to me over the years, and I'm quite sure they've been helpful for very many people. So it's been a great privilege to have you on the show. Thanks ever so much, Dr. Behe, for coming on.
Okay, Julian, it was my pleasure. I'll see you later.
See you. Thank you.
Bye-bye.
Bye-bye.